Okay, 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 okay. Ready, ready, ready? Yep. So, we ready? Let's do this.
I'm looking over there.
What did we do on Monday? What did we do on Tuesday, yesterday?
Yesterday was the
Multi-step equations. So guess what? Today we're kind of doing the same thing, but not. This is what I mean. Today what we are dealing with is something that goes by the name of inequalities. Inequalities, my friends. So here we have a greater than, less than, greater than or equal to, less than or equal to.
Or the equal sign.
Yep, kind of, sort of. So, what do these mean? Do we know what these mean? Less than or equal to, greater than or equal to, yeah. Yes, but how will it be played out? Well, it's quite simple. X is greater than 5, right? Mm-hmm. X is greater than 5. That means X could literally be any number bigger than 5. It could be 5.1 and up, but it cannot be 5 or below. What this means is X could be any number greater than or equal to 5. So it could be 5, but it can't be anything less. So X, whatever the number is it could be 5 or up. That's what these signs mean. Now in school they obviously taught you these tricks. The alligator, right? So you could remember these. For instance, the alligator always has its mouth open to eat the bigger number, right? I realize that confuses a couple of students, believe it or not. So if this helps you, use this technique instead. Draw 3 points on each end of the inequality sign. Whatever side has the 2 points, that's the greater side, right? So X is greater than 5 because there's 2. Those are just tricks to remember this right here. Those are just tricks, nothing else. Good. Show it to me later. So, these are inequalities, right? But in the quiz, for those of you taking your GEDs, you won't just be given a problem like this and be told, how would you say the expression? And then you say, oh, X is greater than or equal to 5. No. It doesn't roll like that. Inequality expressions are given like this. And you're told, solve the following inequality. Well, guess what? Here's a little hint, you guys. You guys ready to see the hint? Inequalities. Sure, it's different from the actual symbol is different from the equal sign, right? These are 2 different meanings. This one over here is saying X, whatever number it could be, is greater than or equal to 5, right? Which means X could be 5, 6, 7, 8, or any number above, any decimal too. This one over here is saying, hey, X is 5. X equals 5, right? These are 2 different meanings. But when given expressions like these, you solve them the same way. There's a little difference, which I'm going to show you in the next example, but solve this the same way you would an equation. For instance, if you want to, you could rewrite it like that and solve the way you would regularly with an equation. That came out too ugly. There you go. Solve this the way you would regularly. So what must you do first? Right? Leaving 3x equals, what's 8 minus 2? Are you lying? So now tell me, what do you do now? X equals what? 2, right? But we're not going to put our final answer as an equal sign. What was the original problem? The original problem was like that, I believe. Was it? No, it was the other way. It was like that. So, sure, you could have erased it or rewrote it with an equal sign. Just make sure your final answer has that right there. And the final answer is that. X is less than 2. You see that? So everything we've done still plays a role here. Equations. Boom, done. You ready? No, we're not ready. No, we're not ready.
For what? What is this?
So there is one difference that you might come across. No, that you will come across, I should say. Okay, so we have this expression right here. Negative 2x minus 5 is greater than or equal to 3. Sorry. What do we do? Yep. Remember, treat this as if you would an equal sign, right? So you add 5, negative 2x. What's 3 plus 5?
8.
Now what do we do? Yes, you are all masters at equations. The final answer is what? What's 8 divided by 2? Negative 2.
X is greater than or equal to 8.
Negative 4, right? And what sign do I put in the middle? This one right here?
Yes. No, switch it because it's negative, right?
Will they switch?
Yeah. So this is the only difference. This right here is the only difference between equations and inequalities, is that this has a trick to it. The trick is, if you ever, and I say ever have to divide by a negative number, this symbol flips. I was just saying that same thing. So you flip the sign in case you ever divide by a negative number. All right? No, you do not flip the sign if your answer comes out negative. No, you do not flip the sign if the original problem was a negative. You only flip the sign when the number that you're dividing by is, if you have to divide by that negative.
Yeah, that makes sense.
Get that?
Yeah.
I do with the answer.
Oh boy.
What?
He's saying that if the answer is negative, it's...
The answer does not, it does not have to be negative. For instance, if
Do a different equation.
no,
Does that help?
For instance, okay, fine, I will. Same one, but different. That's a positive 5. Okay, there's this problem right here. Let's do this example right here. Let's do this example right here. Let's do this example right here. You ready for this example? What do we do?
Subtraction.
And put it on the other side.
What's negative 3 minus 5?
Negative 8.
What do I do now? X is less or greater than or equal to, what's that answer? Negative 4. You do not flip the sign. Just because my answer came out negative, just because this one happened to have a negative, if you do not divide by the negative, you keep the sign the same. You got that? Only when you divide by the negative. Who cares what your answer comes out of, or comes out? As long as you divide by negative, that's when you flip the sign. I promise you that's going to be what gets you guys. I promise you. I promise you. You're going to be going through it as if you were the equation expert, and then your brain is just going to switch off when you divide by negative, and you're just going to be like, keep the same sign. And no, it's not correct. I'm marking that wrong. So, no difference there, right? There is one other thing you need to know about inequalities, which is whatever answer you get, this one right there, you could get that inequality expression and graph it. This is what I mean. Here is an inequality graphed. What's the inequality? What's the inequality that's graphed here? Well, quite simple, really. Here's some rules that you have to know. The shaded part, this whole black side right there, that's what x could possibly be. X is it below or greater than 2? Well, this is below, this is greater. So x is obviously less than 2, right? So x is less than 2, right? Now there's one last thing you need to know. Sometimes you'll see this little sign right there, this little point, shaded in. If it was shaded in, it would be equal to. Because it's not, guess what? That's my inequality sign. Boom, you're done. See how simple that is? So go back to this one right here. X is greater than or equal to negative 4. X is greater than or equal to negative 4. How about we graph this one? With this example, we read the graph and we gave our inequality. How about when given an inequality, we graph it? Okay, let me get my thing out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay. Where should my dot go?
Negative 4.
Should it be shaded in or open?
Shaded.
Because of that line right there, right?
Yep.
Now, x is going to be where? I got a right. I have a left. No, I have a right. I have a left. X is greater than 4, which means x could be any of these numbers.
Negative.
No, I'm confused.
X could be any of those numbers, because any of those numbers are greater than negative 4, right? The shaded part tells us, yes, x could be negative 4, equal to, right? This is how you graph inequalities. Cool, huh?
I forgot.
One last trick. Let's say, obviously if you're given an expression like this right there, the 2x plus 5, whatever, or greater than or equal to negative 3, you must solve first before you ever graph your inequality. That's a given, right? But don't think things are always as it seems. What do we do here? How do we graph this? What do we have to do? Yeah. Your answer is never finished, right? Until your variable is a positive. So guess what? We get this. Kill it. Remember that? You strangle it, you crunch it into a little ball, and you chuck it over to the other side, and it flips the sign of the answer. Negative 4 becomes what? Positive 4. Guess what? Now I'm graphing x is greater than or equal to 4. So let's graph this one. How about that? Where should it go? Boom. And it's filled in, right? Where should my x be? Oh, I messed up. I messed up. This sign had to flip. What was before? There you go. It flipped because if you really think about it, we divided by negative 1, remember? But yes, if you ever have to do the whole chuck trick, just make sure to flip the sign because that's what you're doing. You're dividing by negative 1. So, what's x? Where does x lie? X is smaller or less than or equal to 4. So x could be anything on this side. I know. Okay, one last thing in regards to inequalities. I'm throwing a lot at you, right? No, not a lot. It's just equations. Just if you divide by negative 2, flip the sign. Graphing, yeah, that's going to be the fun one. One last example of something that you might come across. Okay, so now we have this problem. Do we know what to do here? Do we know what to do? No. It's pretty simple. It's actually pretty simple when you really think about it. I'm gonna draw something out for us. Does this work? Yeah. So this is what you're going to do for these type of problems. What's going on? You are going to, again, pretend these signs right there are equal signs, right? But you're going to do it in 2 steps. Pretty much, you are going to ignore this whole side over here. Just for a brief second in time, ignore that. And you solve that part first. So how about we solve that part first? So ignore that part that's there, right? On the right side, and let's do our first part. If we were to If we were to rewrite it, I recommend rewriting it if that helps you. Let's just do this. What must we do first?
Do the negative 3x and put it over on the other.
Good. The 3x wants to be with its other buddy, the 5x. Cancels out. 4 is less than 2x. What do I do now? Yeah?
Divided by 2 on both sides.
What's 4 divided by 2? That's 1 done, right? Then you ignore the one that you just did on this side, and you do that one. It's wherever, think of these signs as your anchor points, right? This middle one is always going to be the one that you do with both of them. But it's whatever is before or after the inequality sign that you ignore. So now we do that side. So if you want to rewrite it, go for it. Let me do it in a different color. 5x is less than 16 plus x. What do I do on this side?
Positive x, put it as a negative x, and put it on the other side.
Good. What's 5x minus x?
4x. I'm the only column off.
Now what do you do?
Divide by 4 on both sides.
X is less than, what's 16 divided by 4? So now we have these two problems, right? Now you just link them. Unite them. Overlap the x's, right? Overlap them. This one goes there, that one goes there, and all you get is 2 is less than x, but x is less than 4. That's my final answer right there. Did you see that? 2 is less than x, but x is less than 4. Do you guys want to know how that looks on a graph?
Yeah.
2 is less than x, x is less than 4. Let's remember that right now. 2 is less than x, but x is less than 4. Okay, how does it look on a graph? Quite simple, really. Negative 1, 1, 2, 3, 4, 5. I don't think I need the negative side. Okay. Where do I put the first point? Open or closed?
Open.
Okay. Where do I put my second point?
4
4
and open.
and it's open, right? X is, X is technically greater than 2, right? Because 2 is less than x. So x, if you really look at it, x is greater than 2. Which means, and x is less than 4, which means it falls in right there.
In between these 3.
That's how it looks graphed. X could be 2.1, 2.4, 2.5, 2.6, all the way to 3, 3.1, 3.2, 3.3, all the way to 3.9, but it cannot be 2 or 4. It could be any of those numbers in between. That's inequalities right there. How does that all sound and feel? Pretty simple? Pretty straightforward? Cool. That, my friends, is inequalities. And that, my friends, is all that you need to do. Ready?
Yep. Yeah, I have a question.
Oh, a question I forgot to ask. Any questions?
Oh,
Oh, the...
for the homework that you
Okay, I got you.